So one thing I want to encourage you to do when you solve these problems is to write a lot. So we have a question with Mary and Barry, who have siblings with a, hello kitty, an autosomal recessive disorder called thalassemia. So what do we mean by an autosomal recessive disorder? Well, an autosomal recessive disorder is a disorder where you have to have two recessive alleles in order to have the disorder. So we're going to come up with our genotype for autosomal recessive. So in this case, we'll use T. You have to be the TT genotype in order to have the disorder. Okay, so now let's move on. So we're looking at Mary and Barry. And one other important thing that I want to know is that if there's information in the question, it's not there to confuse you. It's there because it's relevant. And so Mary and Barry both have siblings that have thalassemia. So that tells you something. It doesn't necessarily tell you something about them, but it tells you about their parents. So let's write down their parents. And this is going to be the same for both of them. So it doesn't really matter which one we're talking about. So what you know by the fact that they have siblings that have thalassemia, we know then that their parents had to be carriers. Because again, in order to have the disorder, you have to have two recessive alleles, and one of those came from mom. The other one came from dad. Sorry, this is very difficult to write like this. So here are their parents, TT. Okay, so here's the kind of tricky part to this, although it's only tricky the first time. Once I explain it to you, it's not going to be tricky at all. So let's talk about Mary. This is Mary's mom. This is Mary's dad. Okay. So if you have two parents who are carriers, you can do the Punnett square. You see that the fact that they had a kid with thalassemia was only a 1 in 4 chance, or 25%. All right, I'm going to take a break here and get a new piece of paper. Okay, I lied. I still have one more thing to say about what I've drawn here before we go on to a new page. So one thing when people do this problem is that they assume that both Mary and Barry are carriers. And so you're tempted to say that they have a 1/4 chance of having a kid with thalassemia. But remember, we don't actually know if they're carriers or not. Because look, there's a possibility. This is a carrier, this is a carrier, but this one, they could have also gotten two dominant alleles. So we have to calculate the odds that they are carriers. So you might look at this and think, okay, well, here's one, and a lot of people at this point are like, well, there's a 50% chance that they're carriers, which makes sense, but is not actually true, because one thing we also know is that neither Mary nor Barry has thalassemia. In fact, if they had thalassemia, they would not live long enough to have children. So we know this is not a possibility for either of them, because if they were homozygous recessive, then they would have thalassemia. So now we're only left with actually 3 options, 1, 2, 3. So the odds that they are carriers are 2/3. Okay, and now I'm ready to move on to a new piece of paper. Okay, so we now know that Mary and Barry each have a 2/3 chance of being a carrier for thalassemia. And so now you have to figure out all of the things that have to happen in order for them to have a child with thalassemia. So there are 3 things that have to happen. First of all, Mary has to be a carrier. And also, Barry has to be a carrier. If either one of them is not a carrier, then there isn't any chance that their child is going to have thalassemia. Now, the third thing is that even if they are both carriers, so say they are both carriers, we can go back to this Punnett square here. Even if they're both carriers, that does not mean that they are going to have a child with thalassemia. In fact, again, we get back to this, there's still only a 1/4 chance that they will have a child with thalassemia. So, all of these things have to happen. Mary has to be a carrier, Barry has to be a carrier, and on top of that, their child has to inherit 2 recessive alleles. So when we're talking about 3 things that have to all happen at the same time, we are going to multiply. This is the multiplication rule. So we've already done most of the work here. We know, as I explained, that there is a 2/3 chance that Mary is a carrier. There is a 2/3 chance that Barry is a carrier. And there is a 1/4 chance that even if they're both carriers, there's only a 1/4 chance that their child is going to be homozygous recessive. So let's multiply all of these together. I personally like to cancel things out. So 2 and 2 is 4. Cancel that out. We multiply this together and we see that there is a 1/9 chance that they are going to have a child with thalassemia. Okay, so let's finish this off. The actual question is what are the chances of having 1 child with thalassemia, but the chances of having 2 children with thalassemia. Unfortunately, unless one of them is cheating on the other, the odds are going to be the same for both children. So we'll say child number 1, child number 2, and again, if we're talking about them having 2 children with thalassemia, this is again a case where we're going to multiply because this is the odds of one thing happening and another thing happening. So we take 1/9. It's going to be the same for the second child. 1/9. And we get 1/81. Sorry, this is really not good. I ordered a whiteboard and hopefully it will be here tomorrow so I can do these problems a little bit easier. So the odds are in their favor. There's only a 1 in 81 chance that they are going to have 2 children with thalassemia.